When describing distributions, researchers tend to agree on 4 main items. And those items can be memorized with this very unfortunate acronym. Welcome to the series. Let's just get right to the timer. All right, before we get into CUSS, let's describe or define what distribution is. In statistics, the distribution of a statistical data set or a population is a listing or function showing all the possible values or intervals of the data and how often they occurred. Cool. So the histogram is one of the best examples of a distribution. Remember that we have frequency on the y-axis, which is showing how many items of each bucket we have. It turns out that showing distributions has everything to do with understanding frequency. Here are a few more distribution examples. Now, let's get to that acronym. CUSS stands for Center, Unusual Features, Shape, and Spread. So far in this course, you've had a little bit of exposure to each of these. Let's dig in a bit further, however. When describing center, it can be as simple as stating the mean or median or mode. Normally, however, when you have rather symmetric data, we tend to use mean as our description of the center. And when we have something that's skewed to the left or right, or irregular in some way, we tend to use median. We actually leave mode to talk about shape. Unusual features are specifically related to describing any gaps or outliers in the data. Generally, a 1 to 2 sentence description usually does the trick. When talking about the shape of a distribution, we use words like symmetric or non-symmetric or irregular or asymmetric, skewed, irregular, unimodal or modal. Oh, actually that's where the mode came in. At this point in this course, this is really all we need for shape for now. Describing spread is normally done by stating the variance or standard deviation if the data set is symmetric. Otherwise, we use the 5-number summary and it does a fine job. Range is sometimes mentioned, but in and of itself, it's not that useful of a measurement. So in this example, I found a data set that had 9,980 women's shoe prices for under $350. Let's use CUSS to describe this data. For center, I calculated the median at $52.40, and since this data is skewed, it's the more appropriate value to report for center. For unusual features, there were a few values larger than 157.39 that are outliers according to the IQR calculation we did in the box plot video. Most notably, however, in the histogram, there are clear outliers around $315. For shape, the data is clearly skewed to the right since the tail is to the right. A lot of people get that backwards. I would say that this data is largely unimodal, although someone might consider it slightly bimodal where there's a slight uptick in prices. This one is possibly subjective, however. Since there isn't a clear bimodal look, I'm going to stick with unimodal. For spread, so variance and standard deviation, remember, is typically used for symmetric distribution, although it wouldn't be wrong to state it. In this example, the standard deviation is 43.15. I'm going to go, however, with the 5-number summary as I believe it's better to show in this skewed case. And that's it. Now you know another way to describe data. I hope you agree that this is a fairly easy concept at this point. I would only add that, and maybe it goes without saying, but although this is an easy concept to get your mind around, you should really practice. Practice, practice, practice. And wouldn't you know it, you're going to have plenty of opportunity to do just that in this course. All right, so in the next video, we're going to talk about normal distributions. Leave any questions or comments you have down in the comment section below. Otherwise, as always, thanks for watching. All right, let's do this.